Hello students, once again welcome to the LJ Institute of Engineering and Technology. Let's start with the course Mathematics 1, and today's chapter is same sequence and series, but today's topic is D'Alembert ratio test and Raabe test. So what is D'Alembert ratio test and what is Raabe test? We will see one by one. So first we will start with the D'Alembert ratio test. If sigma un is a series with its n term not equal to 0 for all n, and if limit this is equal to L, that means limit this, that means ratio, here it is ratio taken of un plus 1 upon un, and this is magnitude which gives answer L, then according to this L, we can check the given series is convergent or divergent. So for 0 less equal to S, L less than 1, series is convergent. That means the value of L is 0 and greater than 0, 0 and greater than 0, and less than 1. That means lies between 0 and 1. Okay, then series is convergent. If L is greater than 1, then series is divergent, and if L is 1, then test, this ratio test is failed. Okay, so this is the normal ratio test. Okay, no need to confuse about this test. You have given that un is given, you have to find un plus 1. Then after getting un plus 1, you have to take ratio of un plus 1 upon un. Taking the limit, you will get the answer L, and according to L, we have this 3 condition. Okay, this is simple. Not, you have to keep remember, series that involving factorial or other products that including a constant raised to power, okay, like this 3 raised to n or anything, are often conveniently tested using ratio test. So we have one clue. If you can see the factorial sign or 3 raised to something raised to power, then 99.99% in that case ratio test can be applicable. Okay, so this is the clue for spatial ratio case test. Okay, so let's understand the ratio test with some example, 2 or 3 example. Test the convergence of series this. Here you can see that factorial is given, so compulsory we can apply ratio test. But if after applying ratio test that L is 1, that ratio test is failed. Okay, so that's why I'm telling 99.99% case ratio test is applicable. Okay, so let's start with the un. This is un, so we'll find un plus 1, that means this n plus 1 upon this n becomes n plus 1 and factorial as it is. Now we will take ratio and limit, so limit n tends to infinitive, un plus 1 by un, so this is our un plus 1 in numerator, here is given, this is our un is in denominator. Now this n plus 1 factorial comes to the denominator and n factorial goes to the numerator. So we have this n into 2 raised to n plus 1, that means 2 raised to n into 2 into n factorial. And in denominator we have 2 raised to n into n plus 1 factorial. So we can cancel out this. And how we can cancel out this factorial? Okay, so we know the factorial formula, that n factorial is given by n into n minus 1 into n minus 2 into n minus 3 up to 3 into 2 into 1. We know. And then if we start from the n plus 1 factorial, then we will start with the n plus 1. n plus 1, then 1 minus, that means product of difference, okay, n. Then n minus 1, then n minus 2 up to 3 into 2 into 1. Okay, so we will apply that concept only. By cancel out this, we have this step, and we have here applied this concept, n plus 1 factorial, that means n plus 1, n plus 2, and so on. But we can say this is our n factorial. So n plus 1 into n factorial and n plus n factorial will cancel out. Now if you put n is equal to infinity, so 1 by 2 upon infinity is 0, and as I told, if L is 0, then we can say that by ratio test given series is convergent. Simple. So these are the so easy method: comparison test, ratio test, Raabe test, root test, so easy. Okay, but frequently asked in examination, so you have to focus on these 4 series. I have already said the name: comparison test, ratio test, Raabe test, and root test after this lecture. Okay. Now one more example. Is the series this is convergent? Here you can find factorial, so you can apply. You can check for the ratio. If it is followed that 3 condition, L lies between 0 and 1, the convergent, L greater than 1, divergent, and L equal to 1, test fail. In that case, we will apply other case. Okay. So let's start with the UN. We have UN. So we have UN plus 1 is n plus 1 raised to n plus 1 and upon n plus 1 factorial. By simplifying this, we will get this. How? So n plus 1 raised to n plus 1 is written as this: n plus 1 raised to n into n plus 1. Base same, addition of power, that means addition of power, we can separate the base. Divide by this n plus 1 factorial is written as n plus 1 into n factorial. And by cancel out these two, we will have this. Okay, by taking the ratio and limit, we have numerator this and this is numerator, and as we know that this n factorial is cancelled out, and by taking n common from this, n raised to n is also cancelled out, and we know the standard limit as we have seen in first lecture of this starting of this chapter. This gives the formula E, and we know the E value of E is 2.71 something, so which is greater than 1, and that's why by ratio test, if this L is greater than 1, so you can say that given series is divergent. Okay, so simple. One more example. Test the convergence of this series. This first of all we have to write down, or we have to find the n. Here you can see that this is 1, so 2 raised to 1. This is 2, so 2 raised to 2. This is 3, so 2 raised to 3. 4, 2 raised to 4. So what is un? N upon 1 plus 2 raised to n. Yes, this is our un. So we can find n plus 1 by putting n is equal to n plus 1, n plus 1. So by taking ratio n un plus 1 in the numerator, this divide by this, so we will take reciprocal by simplifying this. So taking 2 raised to n common from this numerator, so we have, if we take 2 raised to n common, so 1 by 2 raised to n plus 1, which is here, and if we take n common from this, so we have n common, so 1 plus 1 by n. Similar way from here, if we take 2 raised to n common, so we have 1 by 2 raised to n plus 2 raised to 1, so this 2, and this n as it is. So by cancel out this n and this 2 raised to n, we have remaining term is this, and if you put n is equal to infinity, so 1 upon 2 raised to n, 1 upon 2 raised to n, 2 raised to n, n is infinitive. So anything raised to this number base is greater than 1, so this infinitive is infinitive, and 1 by infinitive is 0. So this 0 plus 1, 1 plus 0, 0 plus 2. So we have final answer 1 by 2, which is less than 1, and by ratio test, the given series is convergent. Simple. Okay. So these are the example based on ratio test. Now what is the Raabe test, and when we will apply this test? Let's have a look on the Raabe test. If sigma un is a series with un not equal to 0 for all n, and we have limit of, this time we have limit of this term, n into modulus of un upon un plus 1 minus 1, and limit of this entire term is equal to L. And then depends on L, we can say if L greater than 1, then series is convergent. Totally different. That means if L greater than 1, then in ratio test it is divergent, but in Raabe test it will be convergent. If L is less than 1, then it is divergent, and if L is equal to 1, then test fail. So when we will apply Raabe test, how we know, as we have discussed previous, that if we get factorial or other product or something constant raised to power, then we can apply ratio test. So Raabe test is applicable when Raabe test is applicable when ratio test fails, because if it comes 1, then ratio test is fail. In that case we will apply Raabe test. Okay, so let's have a look on the example so you can understand better. And same process, so in this test we will not take a maximum more example, only one example is enough. So is the series this convergent, question mark. Here factorials are visible, so we will first check ratio test, and as we have seen, ratio test is like this: limit n tends to infinity un plus 1 by un. So instead of this, and it is equal to L, instead of this, if we can find this, yes, we can find this also, but its answer will be 1 by L considered, because if we take reciprocal of this, okay, so reciprocal of this, okay, ready? So why I'm just giving you this hint, because if ratio test fail, then we can apply Raabe test. In Raabe test we need this, that's why. Okay, so un is given already here, so un plus 1 we can obtain by replacing n by n plus 1, and we will find un upon un plus 1 in this time. So un in the numerator, un plus 1 in the denominator, so reciprocal of this. By simplifying this, how we can simplify? We know that 2n plus 2 factorial is written as 2n plus 2, then 1 minus 2n plus 1, 1 minus 2n, and factorial 2n factorial stop, because we have in denominator 2n factorial also, so we can cancel out this. Similar way, this n plus 1 factorial is n plus 1 into n factorial, same to same in the second term, n plus 1 into n factorial, here this and this, so we can cancel out this factorial, n factorial, n factorial, n factorial also. And 4 raised to n plus 1 is written as 4 raised to n into 4 base, okay, splitting the base, so 4 raised to n is also cancelled out. So we have remaining term this, okay, so this is our un upon un plus 1. Now if we take n common, so from this n common, so we have this 2 term, and same with in the denominator, so n square cancel out, and we have this. Now we will apply limit on the both side, limit, okay. So by putting n is equal to infinity, we know that this term is 0, something upon n infinity, something upon infinity, something upon infinity, 0. So 2 into 2, 2 2s are 4, and 4 into 1 into 1, that is 4. 4 cancel out, and we have answer is 1. This is our 1 by L. So L is also 1, and as we told in ratio test, if L is 1, then test is fail. So we will apply Raabe test. And in Raabe test, we need un upon un plus 1, and we minus 1 from this un upon un plus 1. So we already obtained this minus 1. So by taking LCM and all this thing by simplification, 2n, 4n square cancel out. Minus 8n plus 6n is minus 2n, and this minus 4 plus 2 is minus 2, so we have this. If we take minus 2 outside, so we have n plus 1, so we can cancel out this n plus 1, so we have minus 2 upon minus 2 is also cancel out with this, so minus 1 upon 2 into n plus 1. This is our un upon un plus 1 minus 1. Now we will multiply this with n, both the side. So we will get this one. So let's have a look on the next step. We multiply this. So n is here with this bracket, okay, this bracket, and we'll take limit on the both side. By simplifying this, we can take this n common from this denominator. So we have this, by cancel out n. If you put n is equal to infinity, so 1 by infinity is 0. So we have minus 1 by 2. So we have minus 1 by 2 outside, and this is our 1. So answer is minus 1 by 2, which is less than 1. And by Raabe test, less than 1, then it is divergent, not convergent, okay? Because it is different from the ratio test. So Now these are the your practice example. You use pen and pencil and solve these examples by yourself so you can understand better. As I told, this test is also equally most important like comparison test. Okay, so keep practicing, keep learning. Thank you for watching this video. We will see you soon with next lecture. Next test is a root test, which is also most important. So thank you very much.